Now, density is the amount of mass in a unit volume of a substance, and so the formula for that is simply mass divided by volume. Okay, and if you look at all the different densities for substances, what you should recognize is the fact that the density is what determines whether or not something's going to float. So for example, if I have balsa wood, which has a density of 0.16 grams per centimeter cubed, and I put it in water, that balsa wood is going to float because balsa wood is less dense than water. However, if you take table salt and just put it in water without stirring it, it will sink to the bottom because it is more dense than water. So let's actually look at an example problem. It tells me that I have tetrachloroethylene, and it is a liquid that's used for dry cleaning, and it has a mass of 40.55 grams and a volume of 25.0 milliliters. It says, what is the density at this temperature, and will it float in water? Explain. So remember, the formula for density is mass divided by volume. Okay, I'm going to take the mass, which is 40.55, and divide it by 25.0. And so my answer, we will go over this in a future video, but just as review, because 40.55 has 4 sig figs and 25.0 has 3 sig figs, my final answer should have 3 significant figures. So my answer is 1.62 grams per mil. Now, if you look, the density of water is 1.00, which means that tetrachloroethylene is actually going to sink in water because it has a density that is higher than that of water. In addition to the units that we were talking about, one thing that we can do in order to change the size of the unit is by using prefixes. So prefixes are used to indicate the decimal fractions of various units. So for example, if instead of saying liters, you say milliliters, there are 1,000 milliliters in a liter. For micro, if you notice, there are 10 to the 6th micrometers or microliters or whatever you want your base unit to be in that one base unit. So notice, starting with deci and moving downwards, those prefixes make the units smaller. While if you move upwards, those prefixes make the units larger. So the ones that I would really concentrate on if you didn't learn them in first year chemistry would be units such as kilo, deci, centi, milli, and micro, because those are prefixes that we assume you know the relationship for. So the next thing we're going to be talking about, I hinted at significant figures, but let's actually talk about what significant figures mean. And significant figures enable us to acknowledge that there is uncertainty in the measurements that we are going to record. And specifically, there is uncertainty in just the last digit of what you record if you're recording correctly. So for example, if I have a thermometer that measures every 5 degrees Celsius, so let's say I've got 25 here and 30 degrees Celsius, if I measure 27 degrees Celsius, I'm allowed to do that because I'm only allowed to have uncertainty in my last digit. So I am certain that it's going to be 20 something, and so I get to estimate that last digit, the 7. Now, if you wrote 27.0, that would be an incorrect measurement because you would now be estimating 2 digits. So you can only estimate 1 digit. And so a significant figure is simply all the digits in the measured quantity in addition to the uncertain one. So for example, 27 has 2 significant figures. So if you compare 2.2 grams versus 2.405 grams, 2.2 is a less precise number because it only has 2 significant figures, meaning I'm certain of the 2, that it's 2 grams, but I'm estimating the second 2 in the 10th place, while for 2.2405, I am certain of the 2, the 2, the 4, the 0, and it is only the 5 that I am estimating, so it is much more precise. All right, so really quickly, just as a review, if you don't remember how to calculate significant figures, I use a trick using the United States. And so what I say is, all right, if the decimal place is present, then you are going to start counting from left to right. And the reason why I use the United States is because the ocean on the left-hand side is the Pacific Ocean. So if it is present, you're going to count from left to right. Now, if the decimal place is absent, meaning you're on the Atlantic Ocean, you're going to be counting from right to left. Now, there are only a couple of other rules, and the main one is that you can't start counting on a 0. However, if you have already started counting, then you will include a 0. So for example, for 0.034, the decimal place is present, so I am going to count from left to right. Now, I start with the very first number that is provided to me, which is a 0. But remember, you can't start counting on a 0, so I'm not going to include that one. So I only have 2 significant figures for this measurement. The next thing that I need to talk about is significant figures and calculations. So for multiplication and division, what you're going to do is you're going to find the value that you multiply or divide by that has the fewest number of significant figures, and your final answer will have that number of significant figures. For addition and subtraction, instead of number of significant figures, it's going to be the fewest number of decimal places. So whichever value has the fewest number of decimal places, that's the number of decimal places your final answer will have. Now, when a calculation involves 2 or more steps, don't round your answer until the end. Now, if your decimal is extremely long, you can round, but add at least a couple, like 3 extra significant figures, because the issue that you will run into is the fact that you will be over rounding, and so your final answer, if you keep rounding throughout the problem, your final answer will be off. So let's look at a practice problem. So I've got 14.3505 plus 2.65. Well, since I am adding, I'm going to be using the fewest number of decimal places. Well, the first value has 4 decimal places, while the second one only has 2. So my final answer, once I add these together, needs to round to only have 2 decimal places, which gives me the answer of 17.00. For the next example problem, I am multiplying, and so I look at my first number. It has 3 significant figures because you ignore the times 10 to the 4th. That's 3 sig figs. And then 0.2501 has 4 significant figures. And so your final answer will need 3 sig figs, and that's how you get 8.23 times 10 to the 3rd. So if you look at this problem, it tells me that I have a woman that has a weight of 115 pounds, and I want to know what her mass in grams is. So I'm going to first write my given, which is 115 pounds. Now I want to get out of pounds, so I'm going to put that unit on bottom. So for 1 pound, now I'm going to put my mass in grams up top. There are 453.6 grams. And so my answer is going to be 52,200 because I want 3 significant figures. So wherever your unit is, so for example, if it's up top like pounds is, you're going to put the same unit on bottom in order to cancel it out and put on the top what you're trying to get into. If instead it were flipped and pounds were on the bottom, then you would need to put pounds in the numerator in order for those to cancel out. So you're going to come across some of those in this packet.